A group of 10 children includes one pair of brothers, A and B, and one pair of sisters, C and D. The children are to be seated at 10 desks, which are arranged in the 2 rows of 5, as shown below. A and B must be seated next to each other in the same row. A. Find the total number of ways the children can be seated. Since A and B must be seated next to each other in the same row, let's just count the number of possible ways, provided we don't distinguish them. So they may be here, here, and so on. So let's count 1 variant, so 2, 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 variants, and for each variant it may be AB or BA. So we should just multiply by 2. In general, it's 2 factorial because there are n factorial variants to rearrange n different objects over n places. So it's 8 multiplied by 2 factorial, which is 2. And for each variant, we can see that there are 8 remaining places, and there are 8 remaining children which can be arranged in 8 factorial ways. So we should multiply it by 8 factorial, and it's the required number of ways, and we need just calculate it using a calculator, and it is equal to this value. The next, after an argument, C and D must not be seated next to each other. A and B must still be seated next to each other. We find the total number of ways the children can be seated. So the number of the required number of ways can be found as the total possible number of ways minus the number of unwanted ways. But since for both situations, for the previous question and for this, A and B are next to each other, so the situation when, or the number of ways so that A and B are next to each other, we can consider as the total possible number of ways, and it's this value. Why? Because it is calculated provided A and B are next to each other as required, and these variants include that C and D are next to each other, and we need just exclude the number of ways so that C and D are next to each other, provided A and B are also next to each other. So it becomes the total number, the total possible number of ways, and it's when A and B are next to each other, because we need A and B must be next to each other, minus A and B next to each other and C and D also next to each other, so that we get the number of ways A and B next to each other, but C and D are not next to each other. And definitely when A and B are at the corner, and when A and B are not at the corner and are somewhere in the row, there will be different number of ways to rearrange them. So we should consider separately when A and B are at the corner and when A and B are not at the corner. So when A and B are at the corner and there are 4 corners, so AB may be here, 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 or here. So there are 4 variants for AB because there are 4 corners. And again, it may be AB or BA for each variant, so we should multiply by 2 because it may be AB or BA. And if we consider one such variant, for example, when AB are here, let's count the number of variants CD to be next to each other. So CD maybe here, so 1, 2, 3, 4, 5, 6. There are 6 variants. So 6 variants CD to be next to each other, and again it may be CD or DC, so we multiply by 2. But for each variant, for example AB here, CD here, we can see 1, 2, 3, 4, 5, 6. There are 6 remaining places, there are 6 remaining children, so there are 6 factorial variants to rearrange them, so we should multiply by 6 factorial. And minus, and definitely if AB are at another corner, due to symmetry, there will be absolutely the same. There will be absolutely the same result, the same number of ways. And when AB are not at the corner, let's count the number of ways for AB. So AB may be here, 1, 2, 3, 4. 4 variants. 4 variants for AB. And again, ABBA, so multiply by 2. And for one such variant, let's find the number of ways for CD to be next to each other. So CD may be here 1, 2, 3, 4, 5 variants. You may check that if AB are here, you can see that 1, 2, 3, 4, 5, so it will be the same. So 5 variants for CD to be next to each other, and again CD DC, so multiply by 2. And again there are also, you can see 6 remaining places, so there are 6 factorial ways to rearrange 6 remaining children, and you need just calculate it. You may do it directly like this, or you may factor out common factors, and just using a calculator it becomes to be equal to this value. So it's the required number of ways. And that's all for this question.